In this video, we'll be focusing on flowcharts. So what exactly would a flowchart be? Imagine it to be a roadmap with instructions. As you go along this road, you will be asked straightforward questions. Questions to which you should reply with a yes or no type of an answer. So, depending upon your answer, you can either follow the yes path or the no path. This is a typical example of a flowchart. Note that in every single flowchart, it begins with a start circle, just like this one, and every single flowchart ends with a stop circle, and there are inputs, outputs, and processes along the way. These are the basic symbols present in a flowchart. The circle indicates either stop or start. The inclined rectangle indicates either input or output. The rectangle indicates a process or a calculation or work. This over here, the line with an arrow, indicates the direction in which data flows. The data is being processed over here, and this is the direction in which data flows. The arrow indicates the direction. This is a boolean, a decision, a place where you should decide, a question, a straightforward question which you should reply with a yes or no type of an answer. Let's further discuss about this flowchart right here. It begins with a start circle. The input n equals 0. Since it's 0, there are no inputs available yet. So then the data flows, and we meet a boolean or a question where you should decide. They are asking us whether n is less than or equal to 100. N is less than or equal to 100. The answer to that question depends upon this, because n, we mentioned that n is 0. So they're asking us, is 0 less than or equal to 100? Since the answer to that question is yes, display n, the process, display 0. The data flows, and over here is the output. N equals n plus 10. Forget about math over here. This n is not this n. This is an entirely new n, and this n over here is 0, as we mentioned before. Always in an equation like this, in the left hand side, the algebraic expression is entirely new and is not considered to be the same algebraic expression as we mentioned before. In this case, this n over here is not equal to this. This n is 0. So the new n equals 0 plus 10. The data flows, and now this n is no longer 0. So they're asking us 10 less than or equal to 100. Since 10 is less than 100, we go in the yes path. In the process, display n or display 10, and then the data flows again. In the output, the new n equals 10 plus 10. So the entirely new n is now 20. The data flows, and there we see a repetition. This is a sequence, and now the process is being repeated, so there's a repetition. This is actually the second repetition. So now this n is no longer 10, this n is now 20. So in the boolean or in the question, we are to decide whether 20 is less than or equal to 100. Since 20 is less than 100, we still go in the yes path, and in the process display 20. The data flows. The output, the entirely new n is now 20 plus 10, which is 30. The third repetition, and it goes on, and eventually at a moment n is 100 eventually. So in the situation in which n becomes equal to 0, n becomes equal to 100, in the boolean they are asking us, is 100 less than or equal to 100? 100 is certainly not less than 100, but since 100 is equal to 100, we still go in the yes path, and in the process display 100. The data flows, and in the output n is equal to 100 plus 10, so the new n becomes 110. The cycle repeats, and then the new question, or the boolean, asks us whether 110 is less than or equal to 100. Since 110 is not less than 100, and since 110 is not equal to 100, we finally go in the no path and stops. The entire process stops. The cycle ends. The flowchart ends. There are no longer any more repetitions. Let's try a past paper question. So over here, this flowchart also starts with the start circle, as all flowcharts do, and in this box here they say x equals 1, taxi fare equals 0, taxi fare for a car, distance driven by the car equals 6. So in the boolean they're asking us, is x less than or equal to the distance, which means is 1, x equals 1, is 1 less than or equal to 6. Since 1 is less than 6, we say yes and move in the yes path. So in the second boolean, or in the second question, they're asking us, is 1 equals to 2? No, 1 is not equal to 2. So we go in the no path. And as we go along the no path, we meet up a process. So in this process, they say taxi fare, the new taxi fare equals to the old taxi fare plus 35. The old taxi fare is 0, so the new taxi fare will be equal to 0 plus 35, which is ultimately 35. The data flows, and then x, the new x, is equal to the old x, which is 1, plus 1. So the new x becomes equal to 2. And now the data flows again. A repetition begins. In the boolean, they are asking us, is the new x, which is 2, less than or equal to the distance, which is 6. Since 2 is less than 6, we still say yes. Now they are asking us, is x equals to 2? We can finally say that x is equal to 2, so we go in the yes path. And in this process over here, they say the new taxi fare is equal to the old taxi fare plus 50. Now the old taxi fare is no longer 0 but 35. So the new taxi fare is 35 plus 50, which is 85. So the data flows again, and the new x will be equal to 2 plus 1, which is 3. The data flows, and another repetition begins. And in the boolean, they are asking us again, is 3 less than or equal to 6? So the answer to that question is yes. So we still go in the yes path. And in the other boolean, they are asking us, is x equal to 2? Note that we mentioned that the new x is now 3 and no longer 2. So we say no. And the new taxi fare in this process over here is equal to the old taxi fare plus 35. We mentioned that the old taxi fare is 85, so the new taxi fare becomes equal to 85 plus 35, which is 120. So now the data flows again, and the new x becomes equal to 3 plus 1, which is 4. The data flows, and a new repetition begins. And in the boolean, they're asking us again, is 4 less than or equal to 6? Since the answer to that question is yes, x is less than 6 or 4 is less than 6, we go in the yes path. And in the other boolean, they're asking us, is x equal to 2 or is 4 equal to 2? The answer to that question is no. Hence, we follow the no path. And in the process, they're telling taxi fare is equal to the old taxi fare plus 35, which means the new taxi fare is equal to 120 plus 35, which is 155. So the data flows, and now the new x becomes equal to the old x plus 1, which is 4 plus 1, So the new x is equal to flow plus 1, which is 5. The data flows and another repetition begins, and in the boolean they are asking is x less than or equal to the distance is 5 less than or equal to 6. Since our answer is still yes, we still go in the yes path. In the other asking us is 5 equal to 2. We say no, and in the process they are telling us taxi fare is equal to the old taxi fare plus 35, which is 155 plus 35. So now the new taxi fare is equal to 190. The data flows, and now the new x is equal to 5 plus 1, which is 6. The data flows, and in the boolean they are asking is 6 less than or equal to 6. 6 is no longer less than 6, but still 6 is equal to 6, and hence we still go in the yes path. And in the other boolean they are asking us is 6 equal to 2. We say no and follow the no path, and in the process they tell us that the new x is equal to 190 plus 35, which is 225. So now the data flows, and now the new x is equal to 6 plus 1, which is 7. So the data flows, and in the boolean they are asking us is 7 less than or equal to 6. We can finally say no, and in the output they tell us print taxi fare, which means print 225, and then it stops. The entire part ends. There are no longer any repetition at all. Alright, we'll try the last example for today. Draw a flowchart to display the average of 5 numbers. This is how we do it. So, as in all flowcharts, it starts just like that, and there's a bunch of numbers in this box over here. N equals to 1, num, which means number, avg means for average, and tot means for total. All three of them are equal to 0. So in the input we are supposed to enter a number. The shortened form is num. So let's say the number is 1. So no, wait, let's say the number is 0 first of all. So tot, total, is equal to the old total plus the number. So total is 0 plus 0, and over here they say the new n is equal to the old n plus 1, which is the new n is equal to 0 plus 1, so the new n is 1. The data flows, and over here in the boolean they are asking us is 1 greater than or equal to 6. Sorry, over here the new n is not 1 because the old n is 0. Sorry, the old n is not 0 because the old n, as we mentioned before, n equals 1, which means the old n is 1, and hence the new n is 1 plus 1, which is 2. So sorry about that. And now the data flows, and in the boolean they ask us, is 2 greater or equal to 6? Our answer to that question is no, and hence a repetition occurs. And in the input we are supposed to enter a number. Let's enter 1. Okay, so the new total in this process, the new total is equal to the old total plus the number. So the new total is equal to 0 plus 1, which is 1. Okay, now the data flow, and in this process here the new n is equal to 2 plus 1, which is 3. So in the boolean they ask, is 3 greater or equal to 6? We still follow the no path, and a repetition begins again. In the input, let's 2 as the number. So then the new total is equal to 1 plus 2, which is 3. So now in this process here, the new n is equal to the old n plus 1. The new n is equal to 3 plus 1, which is 4. So in the boolean they ask, is 4 greater or equal to 6? No, still no. So the data flows, and in this repetition, in this input here, let's enter the number as 3. So the new total is equal to 3 plus 3, which is 6. So the new total is 6. The data flows, and the new n is equal to 4 plus 1, which is 5. And in the boolean the question is 5 greater or equal to 6? No. So enter a number. Let's enter 4. The new total is equal to 6 plus 4, which is 10. So now the new n is equal to 5 plus 1, which is 6. Now they ask, is 6 greater or equal to 6? Well, 6 is not greater than 6, but it sure is equal to 6, and hence we say yes finally. And in the process we are supposed to give the average, and according to this process or this calculation, they say average is equal to the total divided by 5, since we are speaking about 5 numbers. So the total is 10 divided by 5, which is 2. Display average, and it's 2. Alright, those are all the flowcharts for today. I'll end this session with a question, and the question is, draw a flowchart to display the divisions of 10 in between 0 and 100, between 0 and 100. Alright, thanks for listening. I hope you enjoyed it. That's all for today, and see you again in the next chapter.